They're going to take this up quickly. It seems like most of us are on the right track because it was basically, well, at least 1 and 2 was review of the homework. So midpoint. We specify by capital M. So I want you to note this notation. The midpoint, and I'm going to put a subscript of AB, being the midpoint of the segment AB from points A to B, is x1 plus x2 over 2, y1 plus y2 over 2. So x1 here, this, x1, x2, y1, y2. So negative 2 plus 2, well, that's kind of convenient. Comma, y1 is negative 3 plus 4 over 2. So that gives me my midpoint of AB is 0, because negative 2 plus 2 gives me 0, and I'm left with a half. Okay. It's important to start labeling our midpoints because, and we'll see this later, you will have questions where you're required to find more than one midpoint. So I don't want to see 2 different capital M's and it not being labeled properly because you're not telling me it's the midpoint for one. Okay. For the length of AB, so length formula is L is equal to square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Right, so it's your basic length formula. Start plugging in the numbers. So x2, 2 minus negative 2 quantity squared plus y2 is 4 minus negative 3 quantity squared. That gives me L is equal to square root of 4 squared plus 7 squared. Gives me square root of 16 plus 49. So now it's just the square root of 65. And you can just leave the answer as that. Okay? Now, the arithmetic here is simple, but it's a little bit complicated because there's a lot of stuff to plug in. And towards the end of this unit, it's important you get this right because this is just step 1 of a 4-step process. So if you get this number wrong, everything else is going to be off. Okay? So it's really, we need to take care of arithmetic. Finally, the equation of the line. How do we go about getting that? This is a review of grade 9. I know. Who thought you had to use grade 9 math for grade 10? How do we get the equation of a line that passes through 2 points? Anyone other than 2 people? 3, 4. Mildred? Okay. Well, first of all, let's just start off with what's the equation of a line? Slope. Okay, so I'll remember that y is equal to mx plus b. So we need to really find out 2 values, right? We need to find out the m. We need to find out the b. We need to have actual values for those 2 variables, and then we get our equation. So Mildred, you said slope. How do we get the slope? Okay, so m is equal to delta y over delta x, which is y2 minus y1, x2 minus x1. Does it matter which point I choose for y1, y2? Sorry, point 1, point 2? No? So I'll choose this one as my point 2. So this will be x2, y2. And I'll choose this one to be x1, y1. So y2 is -3 minus 4. And then -2 minus 2. So -3 minus 4 gives me -7 over -4, which is the same as 7 over 4. Okay? So here we have our slope at least. Y is equal to 7 over 4 x plus b. Okay? So we got sort of halfway there. Okay?
Yeah.
So we got the slope. How can we get b though? How can we solve for b? How can we solve for b? Right? So you want to plug in the midpoint line? Okay, why can we plug in the midpoint? Why can we plug in any point on the line? Why does plugging any point on the line give us b? And this is a concept that you really need to grasp. I'm focusing it with my grade 9s because it extends to quadratics. And I'm seeing this year a lot of that concept was not getting across. And that's why we struggle with quadratics, especially towards the end, right? What does y equals something x mean? Why does have point, as Trang said, we take the midpoint, why does that give us the actual value for b? Why is that the case? What's the mathematical justification behind that? As opposed to, oh, it's just something that we do. Adrian?
If you really sub in like any point on that line to solve for
Why can't I just sub in any point on that line?
because it's a parallel line, so you can use any part of that line to actually solve for another part of the line. That makes sense.
Okay. So we have this equation up here, and I actually did this in the first class, that's why it's up here. This defines this line that passes through these 2 points. That means this point is part of this equation. Okay? So what this means is that when x is -2, as part of this equation, what's my value of y have to be? When x is -2? -3. I mean, that's how I actually get that point with that formula, with that equation. When x is 2, what's my value of y? 4, right? That equation defines these values of when x is this, my result is this, right? My x is almost treated as like an independent variable. I set my x, then what's my result of y? The same thing happened when we did with quadratics. Y is equal to x squared minus 3, right? That's what a graph of that equation is. All the possible combinations of x's and y's that make that equation true. Except now we're just doing something funky with it, we're just squaring the x. So when x is 1, what's y? So when x is 1, what is y? Well, you plug in x for 1. So what's y? -2. Right? And we go off and plot that. We plot all the different combinations of x and y's that make this true. We get a thing that looks like a parabola. Well, it would be this one in this case. Okay? So the same thing, I mean, it's just an extension of what we learned with lines. Okay? And we've done examples in quadratics where I give you 2 points in a quadratic. And you have to solve for certain variables. Right? So this is really extension of what we're doing back in grade 9. So here, okay, Trang wants to take the midpoint, which throws me off. but that's okay. I'm gonna show that this works. So what's the midpoint again that we calculated? 0,1/2. So it's dealing with fractions. Do we want to deal with fractions?
Well, it's not really, because you're just multiplying x. We're multiplying 7
Well, we can
by
do it.
0.
So y was a half?
Yeah.
So it's 7, oh wow. Actually, that works out really well.
Who's all saying what you're saying?
Yeah, I know. I was just fooling you guys. So b is equal to a half. Okay? If we take another point under, first class I did, we don't want to work with negative numbers. We just want to do positive numbers. We can do the same thing. So y is 4. So 4 is equal to 7/4 x here is 2 plus b. If we do the arithmetic on here, we get 4 is equal to 7/2 plus b. And then I want to do 4 minus 7/2 for the b. So that's really 8/2. Sorry? This one, because I multiplied by 7/4. So I cross reduce. So I get 7/2. So b is 1/2 as well.
Wait. And then you subtract the 7/2?
And then, because, yeah, subtract the 7/2 on both sides.
Why don't you multiply by 2?
Because there was 7/4 and then my x value was 2.
So you just what'd you do? How'd you get 7/2?
So 7/4 times 2 gives me 7/2.
Oh.
Because I cross reduced the 2, so I'm left with 2 as the denominator.
And then you subtracted.
Then I subtracted 7/2 from both sides, so I'm left with just b over here. So 4 minus 7/2 is going to be half. So no matter what point I chose, I would have got b equals a half. Because again, we're satisfying this line, satisfying this equation. So therefore the equation is y is equal to 7/4 x plus 1/2. Okay? So that was a little bit review of grade 9. Coming back a bit? Yes, Audrey?
So did you find me and you just checked?
No, I just showing 2 different ways. Like I'm just trying to demonstrate I could, no matter what point I chose, whether it's the midpoint that Trang chose, I chose this one, I still got b equals 1/2. I could have chose this one as well, and I would have got b equals 1/2 as well. Okay? So that's 3 different ways we would have got b because we have 3 points on our line. Okay, any questions on that? Okay, so we're going to take this and extend it a little bit, looking at geometry. So we're going to talk about finding the equation of a median. Okay, so that's the title for this section. Finding the equation of a median. Any guesses to what a median is? Average.
The middle number.
Good. The middle number, when we deal with statistics and numbers, it's the middle number. So what do you think it might apply to analytical geometry? We talk about geometry. Yeah, it's the middle of something, right? Anybody taking driver training right now, learning how to drive? Okay, tell me when your classes are so I can make sure I'm off the roads.
That's a good one.
So you know in the middle, it's in the streets and the roads, there's that concrete slab in the middle where people can kind of walk, right? They call that a median, right? Because it's in the middle of the road that divides the 2 ways, right? Don't drive over them. You will wreck your car. The median. One time I was driving at night, driving home, and there's this coffee time on the side. And I saw this guy signal left. And I knew you cannot turn left right into that driveway. I think you know what I'm talking about. It used to be the coffee time. It's on Leslie, right? It's a Japanese restaurant now. You can't turn left into there. I knew that because there's a median there. boom, boom. I was like, holy crow. I'm glad I don't do that car. So do not drive over a median. You'll wreck your car.
Wait, you drove it or the other guy did?
No, I was watching the car in front of me.
Oh, okay.
And I saw him making a left, like signaling. And I'm like, that's a really early signal. But he was doing a really early left-handed turn, right over a median. Okay? So in terms of geometry, here's the definition of a median. It's the line segment. So again, the line segment from the vertex of a triangle to the midpoint. That's where the middle is coming from. The midpoint of the opposite side. In reality, it could be any shape. But you're just looking from the vertex to the opposite side, especially for a triangle. It's the opposite side. Okay, so here's an example. It helps to actually draw a triangle. So you can kind of visualize it. So I'll do that here. So A is -1, -1, pushes you around here. So that's A. B is 8, 3. And C is 4, 7. Okay, so there's my triangle, ABC. So we want from vertex A, we'll go from vertex A. So what's the definition of median again?
It's the vertex of a triangle to the something on the opposite.
So something we can do for you?
I'm just trying to ask that short. I'm trying to bother you.
Well, you bother everyone walking around.
Something bad. So I just dropped the pencil.
Sorry, what's the definition of median again?
Line segment.
The middle point.
The middle point of the opposite side, right? So here we got the middle point, let's say it's like roughly around here. We draw a line from this vertex to the middle of the other side. This is the median. Okay? So we want the equation of this. Okay, so in other words, we want an equation of this line segment, or that line. So how can we get this? There are two things that we need to find first to do this. Adrian?
Position of the left dot.
Well, okay, what's that position? What's that?
That's the middle of the line segment.
Yeah, so we need to find the middle, midpoint of AB. And what else do we need to find to get our, what else? What's the second thing that we need to get our equation? Remember, we're looking for an equation. What's the second thing that we probably need to get? Adrian?
The actual line.
Well, let's just start off with one first then. Okay? So let's find the midpoint of AB.
Is it a BC?
Isn't that CB?
Oh, sorry, BC.
What are you?
What did you guys say this earlier? Midpoint of BC. So the midpoint of BC is equal to x1 plus x2 over 2, y1 plus y2 over 2, those coordinates. So B is 8 plus 4, those are my x coordinates, over 2, and 3 plus 7 over 2. So that gives me 12 over 2, comma 10 over 2. So my coordinates really are 6, comma 5. Okay, so that's our midpoint.
Wait. To find, since it's the midpoints of BC, I choose the vertices
B and C.
Plug B and C, and then
Yeah, because we want to find the middle of that.
I choose which one I want, X1 and X2 and stuff.
Yeah, so here what I did was this was X1, X2, and this was Y1, Y2. But the order didn't matter, right? It was the points we wanted B, C. So really, when we look at a diagram, this look like it's 6, 5. So we find the midpoint. But how can we get the equation though? How do we get the equation, Jenny? Yeah, we need the slope now. Let's do green. Is it your question?
Clarification question. So you're trying to find the length of the green line, right?
No. First I want the equation.
Oh,
Okay, I'm working on the equation right now, sorry. Okay, the length is kind of self-explanatory now.
Right.
Because we got the midpoint. Sorry for the confusion. I focus on, because the equation really is the harder part. So I want to check out this notation, some more notation. We want the slope. So again, we have questions where we have to find multiple slopes, so we need to then label this. So we want the slope going from A, we use subscripts, to capital M, B, C.
With the small m?
So small m represents the slope, right? So we're going to subscript that with our 2 points. What is the slope of these 2 points? So we're going to label the 2 points. So we deal with a capital M. So our first point is just A. The second point is this new point that we created, M, B, C. Right? That's our midpoint between B and C. So here we're calculating the slope between A and this new midpoint.
Oh, double subscript?
Double, I know. We get into higher order math now where like subscript of a subscript.
Wait, M, A, M, B, C.
Ma'am,
But the A, this part's a subscript of that, and this part BC is a subscript of the big M.
script.
It did come out nice on the whiteboard, I mean on the smart board.
Less years.
It looks like this.
It's a scrub script.
Oh, okay.
So here's my slope.
You added so you can differentiate between the two. So you know.
Because you're going to calculate more than one slope in a given equation question now. So you need to identify what slope you're calculating for. So here we get our slope formula delta y over delta x. So A, point A gives -1 minus 5, right? Because this is my y2 or my y1. Minus 1 minus 6, so I get -6 over -7, which is equal to 6/7. Okay, so that's the slope.
Where'd you get the -1?
-1 was my point A, right? So that was -1, -1.
Oh,
So basically, this was my x2, y2. And I treated this as my x1, y1.
And you're getting the slope of the green line in the middle of the triangle?
Yeah, so I'm getting that slope of that green line, because I want the slope of the median. Because I want the equation, right?
right?
Okay?
See on the left side? M. Yeah.
So what I had up here, M. Okay, so basically it's a slope from point A to the midpoint of B and C.
So that's a subscript of the M, and then the BC is a subscript of the A.
The big M. The BC is a subscript of the big M because this is my midpoint of BC. So that's a point, right? So I want the slope from point A to this other point,
Okay.
which is MBC. Caitlin?
That's delta Y.
Yes, it's delta Y over delta X, not AY, sorry. Delta Y over delta X. So given our slope intercept format, we got 6, 7x plus b. So here, how can I solve for b? Which one do I use? I use AB. I can use it, but can I use AB? Oh, sorry, can I use BC?
No, because that's not on the line section.
No. So I can use either A or the midpoint. I had it. There we go. Do you want to use the midpoint? Okay, so the midpoint was 5, y value is 5, when x is 6. That doesn't work right.
What do you do?
Okay, then we just solve for b. So 5 is equal to 36 over 7 plus b. So I should track 36 over 7 on both sides, plus I'm going to convert that. It'll be 35 over 7. Yeah, 35 over 7 minus 36 over 7 is equal to b.
Wait, where'd
How
you
did
get the
6
30
over
from?
7 become positive?
Two negatives.
Negative 6
Oh.
You got the 35.
So I subtracted negative 36 over 7 on both sides. So it disappeared from the right and is now a negative on the left.
No, I
But where
meant
did
the
the 7
green
come
green.
Like up there, negative 6 over
Oh,
7.
because it's negative divided by negative, right? Just cancel off.
Where'd the 7 come from under the 35?
You always have to do it.
I converted that 5 over 1. So this is 5 over 1, but I need a common denominator
I know.
of 7, so I got 35 over 7. Multiply both top and bottom by 7. So here I got negative 1 over 7 is equal to b. So therefore, the equation of the median from vertex A is y is equal to 6, 7x minus 1, 7. So the idea is I just took extension from before, we had 2 points. Now these 2 points actually have meaning, right? We're talking about the vertex and the midpoint.
What does that say? The, after the median.
The equation of the median from vertex
Oh, from, okay.
from vertex
No, it was the from.
from.
Thank you.
So be prepared for a lot of questions like this. And in fact, this is a building block. Pardon? It gets worse than this, believe me. So this is why
Quadratics all over again.
this unit is tough, because you need lots of steps. Each step needs, you need to be precise. You need to be focused in the right answer. Because if you actually do stuff with these equations afterwards, if you got this equation wrong, oh boy. The rest of the question is going to be very difficult to deal with. Okay? Any questions on this? Right? We're just processing that form, right? Equation of a line between 2 points. Now our 2 points have special meaning. So one last thing I want to talk about today. Finding the equation of a right bisector. So again, we talked about this with the donut example. What is a right bisector? So a right bisector is the line that passes through the midpoint or the middle of a line segment at a 90-degree angle. Passes through the middle of a line segment at a 90-degree angle. Okay, and we saw that with the donut thing, right? When we did chords, we did the perpendicular bisector. We didn't have to do any math to calculate that before. Now we're going to learn the math to actually calculate that now. So one other review, is what we should learn from grade 9. So re-jog your memories a little bit. The slopes of perpendicular lines. So we take two lines that are perpendicular to each other. We take their slopes. So the slopes of perpendicular lines are negative reciprocals of one another. Right? So if we have A over B, negative reciprocal of that is minus B over A, right? Take your fraction, flip it, change the sign. And as part of that donut example, that's why I got you calculated, your answer is always going to be, when you multiply it, always going to be -1. Okay? So here's a question we can work with. Find the equation. So find the equation of the right bisector to the line segment AB, where A is 1, 1, and B is 5, 3. So let's sort of break this up a little bit. What are some things that we need to find to help us get there? Slope of AB. So notice the slope of AB. How does that help us? So how does finding the slope of AB help us?
Then we can find the negative reciprocal of that slope.
So if we find the slope of AB, then we know the slope of the negative. Let me rephrase. We find the slope of AB, then we know what the slope of a line perpendicular to it is, which is what we're looking for, right? We're looking for a line perpendicular to AB. So if AB looks something like this, A and B, we want to find a line that cuts it in half, but it creates a 90-degree angle. So we want the equation of this. So to find the slope of AB, this gives us the slope, negative reciprocal, gives a slope of the perpendicular bisector. Okay, you guys remember that symbol for perpendicular? Right, where it's like the upside down T? So that's what we want the slope of AB. What else do we need? What else do we need? Yeah, we need the middle of that line, right? Because that's where the line, the perpendicular bisector has to pass through. It has to pass through the middle of AB. So we need the midpoint of AB. That is okay. So which one we want to do first?
Slope.
Sure, let's do the slope. So the slope, I think that's in green. So the slope of AB is equal to delta y over delta x. So here, I'll choose this as y2, x2, y2, y1, and x1. So I get 3 minus 1 over 5 minus 1. This is 2 over 4, which is equal to 1/2.
Wait, and then 3 is,
So the 3 delta y, right? 3's from here, right? 3 minus 1, and then 5 minus 1. Is that the slope we really want, though? So how to get the negative reciprocal of that? Sorry, Jeannie? Yeah. So slope of perpendicular bisector is -2. Okay. So we want the midpoint of AB now. So midpoint is just x1 plus x2 over 2, y1 plus y2 over 2. So that gives me 1 plus 5 over 2 and 1 plus 3 over 2. That's 6 over 2 and 4 over 2, which is equal to 3 comma 2. Okay, so that's a midpoint. So how do we get our equation now? So how can I get my equation now?
Substitute that into y equals mx plus b.
Yeah, so the equation line starts off with y equals mx plus b. What's our slope going to be? Yeah, -2, so that's where we're taking this, right? So we got that, minus 2x plus b. I get points A or B, and we get solve for b, right? Yes? Take points A and B, plug it in, we solve for b. Yes, Adrian.
I'm drawing a blank on what the small b is going to be.
Pardon?
I don't remember what small b is.
Small b is the y-intercept,
So,
where it crosses the y-axis. Okay? So, let me rephrase. We could take points A or B to solve for this line.
We can use points A or B to sub in for the y.
Yeah, to solve for the blue line. Does that make sense? Is A or B on that blue line?
Oh.
The midpoint.
No. This is where we need to be careful, right? Don't get stuck in a process. Yes, we could use A or B for those other things because they were actually on the line. A and B here are not on the blue line. What's the only point that we know it's on the blue line? Yeah, we could only use the midpoint here. So here the midpoint, so it's 2. So y is 2 when x is 3.
6.
So 2 is equal to -6 plus b. So b is 2 plus 6. So b is equal to 8. So that is a real equation. So therefore, the equation of the perpendicular bisector of AB is y is equal to minus 2x plus 8. Okay? Very long process. So you see now that if we get our slope wrong, we can get the negative reciprocal wrong. We get the midpoint wrong, we get a b value wrong. We get both of these wrong. Way out in left field, right? So that's why we need to be precise with our math with this unit.
If on a test we do happen to mess up the first value, but we continue calculating properly, we still get.
After I curse you under my breath, left, right, and center,
But if we continue calculating properly.
After I curse you under my breath, left, right, and center, why do we get 3 minus 1 is equal to 1? Why cannot we do that?
Because sometimes you can calculate.
Yes, Audrey? Okay, wait 5 minutes. Thank you. Okay, so that's what we need to take care of this stuff, right? It makes my life easier. And believe me, when I'm marking your stuff, you want me to be a happy camper. Alright? Any questions on this? Right? On a test, this is probably at least worth 3 marks. Right? 1 mark to get the slope, another mark to get the midpoint, another mark to get the B value, and probably another mark to slap everything together. Right? So it's a lot of work. But it's only 1 question. And this could be part of yet another question. For example, you can have a question like this. Don't write it down. We're not going to do it today because we don't have time. But for example, think about what we did with the donut. Right? The donut, we had 2 chords, 2 line segments. Right? So here, we have a circle that has these points, let's say. A, B, C. Do I not have 2 chords there? Even though I have 3 points, do I not have 2 chords? Can I not determine the equation of the perpendicular bisector? I just taught you how to do that, right? You need to figure out the slope of this. You get this equation, midpoint. Do the same thing for here. In other words, that question I just did, we have to do it twice. And then the magic question is, from there, how do we actually get the coordinates of the circle? This is where the fun part is.
So much fun.
Right? Go to YouTube, give you tools to answer questions like this, which we won't do today.